We're going to start with some review of what we did at the end of the last class, and then we will extend this a little bit. So remember, our goal with what we're doing right now is to get away from having to use limits to compute derivatives and start getting some nice rules for computing derivatives that will make our life a lot easier. We don't want to have to use those messy limits every time. So at the end of last class, we had determined that the derivative of a constant function was just 0. So this was if I'm taking the derivative of like 7, I'm going to get 0. If I take the derivative of 7 million, I get 0. There's some fun constants you can talk about, like pi is a constant. So the derivative of pi is 0. E is a constant, so the derivative of E is 0. 1 over 10 pi, that's all just a constant. We could type it into our calculator and get a number out, so its derivative is 0. So remember that sometimes constants are going to come disguised to like pi or E, but those are just numbers. And then the other thing we had learned was the power rule. So the power rule told us how to deal with the derivative of x to a power. And the way that we did that, if we look down here, is we brought the 5 out front. We bring that the number, the exponent down. We keep the x, and then we subtract 1 from the original exponent. So 5 minus 1 gives us 4. Okay, so that was how the power rule worked. So we'll just quickly do a couple examples using that information from last class. So you should probably try B through E on your own and then watch my answers here. So for part B, if we're looking at this is just a constant function, 3 is a constant, so the derivative of a constant is 0. If we're looking at x to 11, the 11th, we bring the 11 down, we subtract 1 to get 11x to the 10th. Slope of the tangent line is the same thing as asking for the derivative at that point. So we're going to find y prime is going to be 20x to the 19th. And then we want the slope at x equals 1. So we plug in 1. And that will give us 20 out. So that is our slope at that point. Differentiate, that word just means find the derivative. This is the same thing as saying find y prime, find dy over dx, find f prime of x. Differentiate just means find a derivative. So for this one, we need to rewrite this as x to a power first. This is 1 over x to the 1/3. We don't want that division though. We need to get rid of that division. So this is x to the negative 1/3. Just using rules of exponents. So if we take the derivative, we bring that negative 1/3 out. We subtract 1 from 1/3, and that's going to give us negative 4/3. Okay. So now what happens if we stick a number in front of the x squared? We know how to deal with 4 by itself, and we know how to deal with x squared by itself. Or what happens if we add pieces together? We know how to deal with an x cubed or an x squared by itself, but what happens when we add these together? It's going to turn out things behave very nicely. So with 4x squared, what we're going to do is we're going to say, okay, well, the 4 is just a constant. It's just going to hang out front. So the 4 doesn't change. And we're going to take the derivative of x squared, which is 2x to the first. So we're just going to get 8x for that. That's what this rule here is telling us. This is the constant multiple rule. If I have a constant times a function, I just pull the constant out and deal with the function itself. If I have a bunch of things being added or subtracted, I just deal with the pieces individually and then add or subtract them. So the x cubed becomes 3x squared. The 1 becomes 0 because it's a constant without an x. And then the 2x squared becomes 2 times the derivative of x squared, which is 2x to the first. So this becomes 4x. So we could write that as 3x squared plus 4x. Okay, notice this only works with addition and subtraction. Multiplication and division are going to be a lot messier. So you might want to try these examples on your own first, but I'll go ahead and record them. So this first one's differentiate, so find the derivative. So if I look at this, I keep the 3 out front. The derivative of x squared is 2x to the first. Then I add. This one's just using the power rule, 4x cubed, because I brought the 4 down, I subtract 1 from the exponent. Now we're going to have minus 2, we just keep that constant out front. X is like x to the first, so we bring the 1 down, we subtract 1 from 1 to get 0. 5 is a constant, so its derivative is 0. And then this last piece we can rewrite as x to the negative 3, so we're going to have minus. The derivative of x to the negative 3 is negative 3x to the negative 4. And so let's simplify this. We're going to get 6x plus 4x cubed. X to the 0 is just 1, so we're just going to have minus 2, and then we're going to have plus 3x to the negative 4. Okay, so we're just finding the derivatives of the pieces individually and then combining them together. This next one's asking us for the second derivative. So let's find the first derivative is going to be 2 times 2x to the first plus 7 times 1x to the 0 plus 0, since 6 is a constant. So this is 4x plus 7, since x to the 0 is 1. And then if we take the derivative of that, this is 4 times 1x to the 0th power. 7 is a constant, so its derivative is 0. So we're just getting 4 out for our second derivative. Okay, we're just going to keep chugging along here. This one we need to rewrite before we find the derivative. So this is 5 over x to the 7/5. That's how exponents work with radicals. And then this is minus 5x to the 1/2, since the square root of x is just x to the 1/2. And then let's get this out of the denominator. So we have 5x to the negative 7/5 minus 5x to the 1/2. All I've done so far is rewrite this expression. When I take the derivative, I'm going to get 5 times negative 7/5 x. I have to subtract 1 from this. So what's that going to give me? 7, 8, 9, 10, 11, 12. Okay, negative 12/5. Sorry to do that calculation on my hand. And then I'm going to have minus 5 times, I'll bring the 1/2 down, x. I have to subtract 1 from this. That will give me negative 1/2. Okay. So if we multiply this out, those cancel out. So we're going to have negative 7x to the negative 12/5 minus 5/2 x to the negative 1/2. Okay. We're going to do 2 quick examples here before we finish up. We'll do so many of these in class, so don't stress if these are a little interesting to you. This one has multiplication. We don't know how to deal with multiplication, so we have to simplify this first. So go ahead and FOIL that out first. So if I FOIL that out, I'm going to get x squared. I have minus 2x plus x, so that's going to be minus x minus 2. Now there's just addition or subtraction, so I can take the derivative. X squared becomes 2x to the first. X just becomes 1, because remember that's going to be 1x to the 0, which is just 1. And then minus 2 becomes 0. So we're going to have 2x minus 1. Okay, so when we have multiplication right now, we need to rewrite that before we can deal with it. Same is going to be true about division in this piece. So we can rewrite this as 3x squared over x squared plus 4x over x squared plus 1 over x squared. X squareds cancel out, so we're left with 3. And x cancels out here. So this will be 4x to the negative 1, because it's 4 over x to the first, but we need that x not in a denominator. And then this is plus x to the negative 2, just rewriting that. So all I've done so far is rewrite this. Now I have to take the derivative. So the derivative will be, the derivative of 3 is 0. Then I'm going to have plus 4 times, bring the 1 down, so negative 1x, subtract 1 to the negative 2. And then I bring the negative 2 down, and I subtract 1 to get negative 3. So this looks like negative 4x to the negative 2 minus 2x to the negative 3.